Hey everyone, thanks for checking out the video. Today we're going to be looking at topics from Unit 1. So starting with today's do now, what value of x would make lines Q and R parallel? So right now Q and R look like they're parallel, but again, that's never enough to say that they are and treat them as parallel lines. We need some sort of relationship to prove that they are parallel. So we're going to be looking for things like alternate interior angles need to be congruent, alternate exterior angles, if we have a pair that are congruent, we're good, or if we have corresponding angles that are congruent, then we can say that the lines are parallel. So always in situations like this, fill out as much as you can using the relationships we've learned, like vertical angles, supplementary angles, complementary angles, whatever. So here's 25. This angle over here, since they're both formed with these two lines, this angle over here needs to be 25 as well, since they're vertical. And we could do the same thing if we look at this line and this line. 85 is vertical to this one over here. Okay, any other information? Well, we know that this is a triangle, so if we had one more angle, that would help us figure out x, right? But we don't have that yet, so let's look for some other relationships. Yep, here's one. Here's a straight line, which we should know is 180 degrees, or straight angle. This angle, and this angle all combine together to make that 180 degrees. So if I have 25 and 85 together, this is 110. So that must mean this leftover piece has to be 70. So this one is 70, meaning this one is vertical to it, so it's got to be 70 as well. Okay, we have a lot filled out up here. Now, let's try to see if we can have any relationships here. Well, if we had the parallel lines, if these were parallel, then we'd either have this one as a transversal or this line as a transversal. And then I could look for alternate interior, 25. This one would have to be 25, right, for congruent alternate interior angles. But we're not looking for this angle, we're looking over here. So here we go. This one's 70. This one has to be 70, because that would be alternate interior. They're on alternate sides of the transversal inside the two parallel lines. So if this was 70 and this was 70, then the two lines would have to be parallel. Okay. Here's some topics. You need to know how to name points, lines, planes, rays. Angle addition postulate. You can add angles up together. That's what we used in our do now. Segment addition postulate, angle relationships, vertical, complementary, supplementary, parallel lines cut by a transversal, and the special angles they form. Or if we don't know that the lines are parallel, how can we use relationships to prove that they are? Triangle angle sum theorem. All angles in a triangle add up to 180 degrees. Isosceles triangles have two congruent legs and two congruent base angles. And equilateral triangles, all the sides are the same length and all the angles are the same measurement, which always turns out to be 60 degrees. Okay, let's warm up with a couple more. What is the relationship here? Well, we have two straight lines and angles on opposite sides. Those are vertical, and we know that vertical angles are equal to each other. So we need to show that algebraically. 2x plus 29 equals 5x plus 20. That's it. The geometry piece is that they're vertical angles and that they're congruent to each other. The algebra piece is actually setting it up and solving from there. So let's go ahead and So how do we do this? We would subtract 2x from both sides. So sloppy, sorry, 2x, and get 3x plus 20 equals 29. Well, we have the variable on this side, we want to isolate it, so we subtract 20 from both sides. We're here, 9 is 3x. Divide both sides by 3, and we get x is 3. Okay. How about this one? What's the relationship here? Are these ones congruent? Well, they're not on opposite sides of the intersecting line, so they can't be congruent. But they are right next to each other on the same straight line, so their relationship is that they're supplementary. And you should think of supplementary angles as having 180 degrees. So let's show that algebraically. 3x plus 22 plus 3x plus 128 equals 180. This, I'm going to get some color in here. This angle and this angle together are on this straight line, so they make 180 degrees. So we need to write a relationship that shows that. Using some algebra, combine like terms, and then balance your equation. You should be able to solve for x, so I will let you do that. Alright. Some problems give you a little bit of a paragraph and then a diagram. Whenever that's the case, always take the information from the paragraph and put it directly onto the diagram, because that might help you see some other relationships. So, in the accompanying diagram, line CD is parallel to line EF. So I know CD and EF are parallel. I'm told that, so I can make these markings to say that they're parallel. And AB is a transversal. The measure of DGH is 2x. So I'm going to put in a little 2x there. And the measure of FHB, let's see, FHB, so we're talking about this angle in here, is 5x minus 51. 5x minus 51. And then I'm looking for the measure in degrees of BHE. So BHE. So we're talking about this angle right in here. Well, I don't really know how to get that angle, but I do see a relationship between these two. There's something going on here because we have parallel lines. What type of relationship are these two angles? Well, they're corresponding lines, corresponding angles. And we know that when we have parallel lines, that corresponding angles are congruent. So we can set up some algebra. 2x equals 5x minus 51, since they are congruent to each other. A little bit of algebra. Let's see. People do this differently. For some reason, I always like to have positive x's whenever possible, so I move things over so that they're positive x's, but you might not do it that way. So I'm going to do it like this. And again, this is not the only way to do it. We could be moving the variables to the other side. I just oddly like it to be like that. Okay. Add 51 to both sides. Add 51 to 0. And we get positive 51 is equal to 3x. Divide both sides by 3, and we get 17 is x. Now, are either one of these angles 17? No. The value of x is 17. So this one's 2 times x. 2 times 17, I'm going to get my eraser now. I'm going to say is 34 degrees. But if these ones are congruent, well, shouldn't this other one be 34 degrees also? So I'm just going to erase all that other stuff, and I'm going to write in 34. I could have plugged 17 into that expression here, 5 times 17 minus 51, and I would have gotten 34 also, same thing. So how am I going to get this angle? Well, they're on the same straight line adjacent to each other. That makes for a supplementary pair. So if we take 180 degrees, let's use a calculator, 180 degrees minus 34 degrees will give me 146. There we go. The measure of BHE is 146 degrees. Okay, on to our next one. In the diagram below, transversal TU, so that's right here, intersects PQ and RS at V and W respectively. Now, I don't know if these lines are parallel because there's nothing here that has told me that they're parallel. There are no no markings here that have told us that they're parallel, so we can't assume they're parallel. Just keep that in mind before we even get started. The measure of TVQ, let's see, TVQ, so this angle right in here, is 5x minus 22. I'm going to type it in this time. Make that small. Okay. And the measure of VWS is 3x plus 10. 3x plus 10. Shrink it down. Okay. For which value of x is P parallel to RS? PQ parallel to RS. Same thing that we worked earlier. If these are parallel, then this angle must be the same as that one. The reason being is right now they're in corresponding positions. See this intersection? This one's in the top right. See this intersection? This one's in the top right. If they're the same, the corresponding angles are congruent, and that only happens when you have parallel lines. So another basic algebra, 5x minus 22 equals 3x plus 10. I think you guys know how to solve it once it's set up, but the geometry piece is if these corresponding angles are congruent, then the lines are parallel. So we can set up an equation to try to make them congruent. Okay. Let's see, did we miss something? Okay. In the diagram below, line PQ intersects M and N. So here, line P intersects M and N. And then we have some markings in here for those angles. If measure of angle 1 is 7x, and the measure of angle 2 is 5x plus 30, sloppy. Okay, lines M and N are parallel when x equals. Okay, are these relatable to each other? Well, yes, this angle and this angle are alternate interior. Here are the parallel lines. They are inside the parallel lines, and they're on alternate sides of the transversal. One's on the left side, one's on the right side. So if alternate interior angles are congruent, then we can prove that the lines are parallel. How do we show that? Well, algebra again. Solve this, and I'm sure you can figure out the value of x that would make it true. Again, for proving lines parallel, if you can prove or show that corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary, same side exterior angles are supplementary, then you can prove that you have parallel lines. Alright, find the values of x that would make line S parallel to line T. Same thing, right? Same idea. Let's see, are these relatable? Is 2x plus 6, well, they can't be alternate interior because one's outside the parallel lines, right? Here's my parallel line. They can't both be alternate exterior, even though they're on alternate sides. This one's inside the parallel lines. That's not good. So, what's our relationship here? I can't think of one. So the only thing I can do is diagram some more information out on things I know. These two are vertical, so I'm just going to put 2x plus 6 since they're the same. Now I see it. We have parallel lines cut by a transversal, and I have two angles right here. In order for these two lines to be parallel, these are same-side interior angles, and as you should know, same-side interior angles are not congruent because one's acute and the other one's obtuse, but they are supplementary. So we need to show that algebraically. 2x plus 6 plus 4x equals 180 degrees. If we combine like terms, what do we get? 6x plus 6 equals 180. Subtract 6 from both sides. 6x equals 174. Take out our calculator. 174 divided by 6. We get x is 29. If x is 29, I can plug in x here and x here, and then I'm going to get values that when I add them up, they make 180 degrees. Here, let's double check. 4 times 29 is 116, so this is let's use a different color. This one's 116, and 2x, 2 times 29 plus 6 is 64, 64. Yep, those two add up to make 180. Yes, they are supplementary, so therefore the two lines are parallel. Triangles, my favorite. Whenever we're working with angles in a triangle, we should know that they add up to make 180 degrees. A little bit of algebra shows that. X plus 15 plus 2x plus 1 plus x equals 180 degrees. Combine like terms, balance the equation, you'll figure out the value of x. So let's see, this becomes x and a 2x and an x together is a 4x. 15 and a 1 is a 16, equals 180. All I'm doing is taking the x's, putting them together, taking the constants, putting them together, and then rewriting. So 180 minus 16 is 164. 4x equals 164. 164 divided by 4 is 41. X is 41. Okay. So this angle is 41. This one is 41 plus 15. So this one's 56. Or maybe I should write it on the inside. That one's 56. And then the other one is 2 times 41 plus 1, 83. And the question said, what is the largest angle? Well, now I can look at the three angles and tell that this is the largest angle and state it. And here's my work to justify it. And if I plugged in, if I was doing this on paper, I would have taken 41 and done 2 times 41 plus 1 and shown all that work to get the values. Okay. Find the values of x, y, and z. Same thing. Angles add up to 180. 60 64 and 30 together make 94. So 180 minus 94 is 86. This one must be 86 degrees. Wait a second, this one and this one are right next to each other on the same straight line. They are supplementary. 180 minus 86 is 94. I have two out of the three angles. I have this one, and then we have this angle here. So 20 plus 94, 180 minus 114, 66. And that's how we go ahead and solve. In the diagram of triangle KLM below, measure of angle L is equal to 70. That's diagram there. Nice. Measure of angle M is 50, already in there. Perfect. And MK is extended through N, so it just extends through the angle. What is the measure of? LKN. LKN. So that's that exterior angle right here. Well, if I know this is 70 and I know that's 50, that's 120, right? So 180 minus 120 will give us 60. So I have all the angles in the triangle. How am I going to use that information to get this exterior angle? Supplementary angles. This one and this one add up to make 180, so therefore it must be 120 degrees. 120 degrees. All we did was we used the fact that the angles in a triangle add up to make 180 degrees. Figure out this angle, then we use supplementary angles to get this missing angle on the outside, the exterior angle. Two big ideas for this problem: 180 degrees, triangle angle sum theorem, and supplementary angles add up to make 180 degrees. Thanks for watching. Please feel free to go back and work on any problems and rewatch anything you didn't understand, and ask us if you have any questions. Thanks.